This video will be dedicated to the practice redemption task outcome 3 for the number patterns and sequences topic found in chapter 8. The amount of questions in here are just one, but it's split up into 4 parts. There is a lot of context involved with this question, but as long as we can dissect the question up and use a relative maths accordingly, we should be fine. Let's go ahead and look at the first question. Question 1, for quality assurance purposes, the military must make sure that their jet's speed, which is in kilometers per hour, on takeoff must always be at least double of the previous second's speed. All this is saying is that when a jet takes off within the runway, that in one of the first seconds that it travels, first second, it's going to travel a certain speed of some sort. Within the next second, that speed must be at least double the previous speed. So in essence, it needs to travel faster and at least twice as much. So at least twice. If it's traveling less, then it's not up to standard. A test to determine if the military meets these regulations is applied into a jet that is initially traveling at 5 kilometers per hour for its starting takeoff speed. The quality assurance team randomly selected the jet from its lineup. The jet's initial speed was captured at 5 kilometers per hour. The next second had the speed captured at 11 kilometers per hour, and then the second second, yes, that makes sense, had a clock at 24.2 kilometers per hour. From this, we're going to find what the common ratio from the quality assurance team's test was. Now this is simple because we know if it's a common ratio, then we're dealing with a geometric sequence and it's increasing, so it's a geometric growth. In order to do that, I can see 3 different speeds. We're just going to grab one of them and divide it by the previous one. So let's just double check to make sure that this works for both of them. Let's put in 11 and we're just going to divide this by 5. This will give me the answer of 2.2. So the common ratio is expected to be 2.2. Let's just double check with the next one, 24.2 divided by 11. Again, we get 2.2. So to write this for this common ratio, let's just put 24.2 divided by 11 is equal to 2.2, which is also the same as 11 divided by 5, which also gives me 2.2. The common ratio R is equal to 2.2. Remember, it is big R when it's dealing with common ratio. Remember, if it's a small r, you're dealing with a rate. I'm now going to set up a recurrence relation to model the speed of the randomly selected gem. For the recurrence relation, we always start off with whatever the letters associated with it is. Now, if there are no letters associated with this, in this case there isn't, we can come up with our own letter. For consistency's sake, let's just use V. So V of 0, so at the initial time, this is equal to 5 kilometers per hour, or just 5. To get the next term, V of n plus 1, we get the previous term and we just multiply this by 2.2. So to get the next term, V of n plus 1, get the previous term, V of n, and multiply it by 2.2. Remember, when you're doing a multiplication, when it comes to the recurrence relation, you always put the number in front and the letter afterwards. You don't have to put any symbol in the middle, because when there is a number and a letter together, it's implied that it's being multiplied. So C says, did the randomly selected jet fulfill the regulation needs by at least doubling its speed per second? State why and back this up with figures. Well, we can see this by this common ratio. Yeah, it's 2.2, which is technically greater than double the amount. And you can see here, 5 kilometers, at least double this. So if we double 5, 10, it has to be greater than 10 the next speed, for the next second, which it is, it's 11. And then in 11, it should be at least double, so we should get something greater than 22, which we do, is 24.2. But again, we can just see through here. So state why and back this up. So we can say that it did it did fulfill the regulation, so we can say it did, because the common ratio in bracket 2.2 is greater than 2, or greater than double. In math terms, that would just be 2.2 is greater than 2. And the last part, we're going to complete the table below of the speed of the jet based on its second to 3 significant figures. Now we already know what the initial speed is. It is 5, and we don't need to write kilometers per hour because that's already within the table to indicate that whatever this number is in kilometers per hour. So we've got 5, and then the next one is 11, and then the next one is 24.2. All you need to do is just keep multiplying this by 2.2 to get the next terms. Now you can do this via the calculator, or you can do this via the table. I'm going to use the table via the sequence function. So my recurrence relation is just 2.2 multiplied by, in this case, a of n, and I want to establish my initial as 5. And we're going from 0 to 5. And just to make sure, we should get 5, 11, 24.2 as the first 3 terms, and then the next 3, 53.24. Now it does say to 3 significant figures, so 53.24 is just going to be 53.2. The next one is going to be 117. And then the last one is going to be 258. This will become an 8 because the decimal, other decimal there's a 6, which is greater than 5. It will bump the previous number up by 1. So it's 258. Now remember, it says 3 significant figures, not 3 decimal places. This here, 3 significant figures, so is this here. These technically are, they will just have 0.00 or 0.0 next to it. But here, the fourth and the 5th second, these are 3 significant figures, and we don't necessarily need to put in the decimals afterwards. But as a consequence, we just have to make sure that it is rounded correctly. And this is all you need to do for outcome 3. If you need to look into outcome 1 and 2, there are other videos in relation to this. Until then, take care, and I'll see you soon. Bye-bye.